At the core of modern artificial intelligence lies machine learning, a discipline that teaches machines how to learn from data and make decisions without being explicitly programmed for every task. It's the technology behind everything from personalized recommendations to fraud detection, and understanding its fundamentals gives you the tools to unlock the true power of AI. Machine learning isn't a one-size-fits-all solution. It comes in different flavors, each suited to different types of problems. The most common is supervised learning, where we train a model using labeled data. Imagine showing the system thousands of past emails, each labeled as spam or not. Over time, the machine learns patterns that help it predict new, unseen emails. Then there's unsupervised learning. Here, the system is left to its own devices, it's given data without labels and asked to find structure. This is how customer segmentation works, or how hidden topics are uncovered in large volumes of text. The third type is reinforcement learning. Think of it like training a dog, through trial and error, rewards, and penalties. Reinforcement learning is used to teach robots to walk, or game mice to outperform humans, by encouraging success and penalizing failure over time. But learning types are only the beginning. The approach you take to problem solving, deterministic or probabilistic, matters too. A deterministic approach will always yield the same result for the same input. It's clean, rule-based, and predictable. But the real world is messy. That's where probabilistic methods shine. They deal with uncertainty and provide likelihoods instead of absolutes, which is vital in domains like risk forecasting or medical diagnosis. Sometimes, you don't have time to test every possible solution. A brute force approach will check every option but is slow and computationally expensive. In these cases, a heuristic approach offers a smarter path, an experience-driven shortcut that doesn't guarantee perfection but gets you close enough, fast. And behind every good machine learning model is one unshakable truth: the data representation often matters more than the algorithm itself. This is where feature engineering comes into play. Let's say you're trying to predict whether a user will stop using your app. Raw data might not reveal much. But create a new feature, like days since last login, and suddenly, your model gets sharper. These crafted features often carry more predictive power than any off-the-shelf algorithm. Sometimes, however, too many features can hurt you. This is known as the curse of dimensionality, when having too many input variables makes your model overfit, or struggle to generalize. That's when feature reduction techniques like principal component analysis, PCA, help, by distilling the data down to its most essential components. Text data poses its own challenges. Machines don't read like humans, they need numbers. That's why tokenization, splitting text into chunks like words or characters, and vectorization, converting these chunks into numeric representations, are essential. Techniques like TF-IDF and word embeddings help turn sentences into vectors that machine learning models can understand. So what are the key takeaways? First, machine learning is powerful because it allows systems to improve through experience. Second, it's not always about the algorithm. Often, the most impactful work happens before modeling even begins, during data preparation and feature design. Third, understanding the nature of your problem, whether it's uncertain, complex, or rule-driven, guides you to the right learning type and problem-solving approach. Let's look at a few real-world cases. A real estate company uses supervised learning to predict house prices based on historical sales data. A marketing team uses unsupervised learning to group customers into segments based on behavior. A robotics lab uses reinforcement learning to teach a robot how to walk, rewarding each successful step forward. Meanwhile, a churn prediction model becomes far more accurate when someone thinks to include a feature like days since last login. And a customer feedback analysis system converts thousands of product reviews into word vectors so it can analyze sentiment automatically. Understanding these fundamentals doesn't just help you build models, it helps you ask better questions, interpret results more clearly, and design systems that actually work in the real world. You're not just learning machine learning. You're learning how machines learn, and how to make them work for you.